Hello, hello. Good afternoon. All right. Hey, I'm Zoltan. I'm with Zscaler. I help run the cloud workloads team here. So what that means is, for Zscaler, interestingly enough, after all these years, a lot of folks still see Zscaler as protecting users, as basically a proxy in the cloud. Many folks don't know we have expanded our portfolio many years ago well beyond that. So that's what we're trying to kind of talk about today, is how we're protecting workloads, servers in the cloud, from a networking perspective as well as for data, right? End of the day, security is about protecting your data and not letting bad stuff come in. So I'm a little bit biased because I'm on the networking side of it, but networking is just half of the puzzle, right? We have to be able to protect data. So there's out-of-band, API calls, stuff that you can't solve from the networking perspective. But at the same time, surprisingly, a lot of folks don't realize that we still have to actually secure our workloads from a networking perspective. And that can actually help us from a transformational perspective. So today, from a Zscaler portfolio perspective, we're going to talk about just those two things: outbound security, and what I will say is inbound security, and how we can actually reduce the need to have inbound security when it comes to accessing your private applications in AWS and potentially other cloud providers and data centers. Because the reality is, many folks still have applications that are in different locations, right? So let's start with the networking piece. Right? From a networking perspective, historically, what I'll say is, many times when we had data centers or colos, unless you're a brick and mortar shop where you had hundreds or thousands of stores, a lot of times from a networking perspective, right, we had east-west traffic and we had north-south, right, going out to the internet. We had some inbound traffic, but we also kind of had really big silos, if you will, right? I would also say that it was easier to protect those data centers than cloud. And there's one reason why, is we only had a few of those locations. You can say the data center might have had many networks within it, so the blast radius of getting compromised could have a bigger effect. But I would say it's a few locations. What happens when we expand into the cloud? That's kind of the beauty of cloud. Now, of course, this is AWS here. Many organizations are standardized on a specific cloud, but through acquisitions and mergers, you might have multiple cloud vendors, right? Now, I was trying to depict this in a better way. The reality is, many organizations don't just have like 5 AWS regions. Many large organizations we work with could be in 10, 20 plus regions. And each of these clouds isn't just like a single data center, right? Each of these clouds could be a hub, a transit gateway hub with 20 VPCs, 50 VPCs, 100. So you could have hundreds or thousands of micro data centers or VPCs. That could be production, development, non-prod, all mixed together. When you take that, you start kind of connecting the networks together. And I'm not talking about any type of specific transport. I'm just talking about routable networks. We kind of click it all together. You might think this is a little bit exaggerated, but when you start applying the same traditional networking concepts, and you might say, well, I can apply some ACLs, put some firewalls into these different places. The point is, you're kind of creating a full routable network. This gets very complicated. And I'm trying to point and not get in front of the whole screen, but right, I can have a VPC, and I could be a developer or maybe IT architect. I might spin up a Windows desktop where I just want to browse the internet in some VPC, or spin up a Linux box and do a quad zero inbound security group, SSH into it, maybe do a Apache web server, leave it up and running and say, no big deal, this is a dev environment. Well, what if it's connected to the rest of my network? It could potentially move across to other environments, right? There's always going to be the potential for human error from a networking perspective. If you look at a footprint like this, again, think about having all these regions, all these VPCs. Do you know what your traffic looks like? Whether it's internal traffic or even what traffic's going out or in from the internet. You don't, it's really difficult to see what's actually happening from a network perspective. There's no magical tool though, right? So what we're kind of proposing here is, what if we take that and we zoom in? I know we can't, we're 20 minutes, I tend to talk too much. So from a networking perspective, I'm going to probably make an assumption a lot of folks are probably using Transit Gateway or possibly exploring Cloud WAN. Some folks I'm working with are actually doing more individual or isolated VPCs, or a combination thereof. Regardless of your network architecture, there's going to be complexities, right? There's going to be different security stacks you could potentially put in place. One thing I've actually noticed is a lot of customers that have secured their users and even data centers don't have equivalent security in different cloud providers. But from a network perspective, you're maybe sending all your traffic out directly, or maybe you're putting some virtual firewalls, but it's not the same level of security as maybe your data center or your users. But again, the amount of complexity varies between every customer's environment. What if we can take a simplified approach? Zero Trust Exchange, think of it at a high level as kind of this global security footprint, Zscaler. Think of all that security stack, right? Proxy, firewall, IPS, SSL inspection, threat inspection, inline DLP. Think of everything that you would do from a policy inspection perspective, that the heavy lifting, the compute required to do all of that is not running in your ownership, right? That is happening in Zscaler's cloud, for lack of a better word. And instead of you having to do that, you're basically doing connectors. You're deploying lightweight connectors that are inside-out connections to Zscaler. Again, this is a little bit oversimplified, right? High-level architecture. So at a macro segmentation level, right, each of these little cloud blobs could be a hub, right? This could be my production transit gateway, US East 1. That could be my non-prod. It could be a VPC island. It could be data centers. The point being, all of these are segmented islands with an inside-out connection to the Zero Trust Exchange. So whether I have workloads, right, this could be anything running in a VPC. It could be a Lambda function that's configured to run in VPC, EC2 instances, anything making API calls, trying to get software updates from the internet. Unlike users that do random internet queries, we do random behaviors on the internet. Servers have more, prescriptive, transactions. We can be a lot more granular and more prescriptive on what we're blocking from a policy perspective, but the point being is we're not connecting all our networks together. And I can actually configure very granular policies in Zscaler that says, hey, I have this environment, and it could be tag-based or attribute-based policy. It says, hey, I have certain workloads here, and I need to have them access a particular database in this other AWS environment. Or maybe I have an AS400 mainframe in my data center still. I don't have a routable network between these environments, but I want to broker access. I can do that through Zscaler, again, without a routable environment. So it kind of makes everything dark and invisible to each other, and the point being is we're trying to broker application connectivity instead of network connectivity. So this whole concept stems from being able to do that for users. That's how we started about 17 years ago, of securing users, whether they're remote or in the office, and extending this to your non-human entities. And we're focused on cloud workloads here, but that can apply to devices like camera systems, IoT systems, servers in your physical world as well. Now, if we zoom in, that's kind of what we kind of consider to be macro segmentation. I almost consider macro segmentation to be a site or a location, a VPC, a VNet, etc., to another application. If we zoom in a little bit more, there's another thing, of course, called micro-segmentation. That's another journey Zscaler is going on now. We believe that micro-segmentation, which is more when we're getting into let's say an EC2 instance to another EC2 instance in the same subnet, within the same VPC. subnet to subnet within the same VPC. An agent-based microsegmentation, that's going to be more for your crown jewels. That's not necessarily going to be something you're going to do across your whole entire enterprise. Because again, my opinion and a lot of the historical kind of data we've seen with a lot of previous microsegmentation deployments, if we go back to that previous visual, right, if you have thousands of VPCs, if you're a very large customer of AWS, you're not going to have all EC2-based instances, right? You're going to have a lot of PaaS offerings. You can't put an agent, do true micro-segmentation there, right? But for the instances that you can, you want to focus on your crown jewels, right? So what we're trying to do is, again, is that defense in depth, that whole stack where use the right tool from a vendor for the right solution. So that allows you to get more granular within a specific VPC. So if that makes sense, again, we focus on doing macro segmentation, and then for the really important stuff, being able to do the micro segmentation within those specific VPCs. All right, got about 8 minutes left. Now, that was all the networking piece. And you might be wondering, well, what does that have to do with security? Again, the approach that my team takes with customers is the way that you architect the network and how we kind of plug in the Zscaler security stack is purely about architecture. And the more we can minimize that attack surface and the blast radius is, if something does get compromised, the smaller that blast radius, the better it is. Because things can happen, right? Things do get compromised. And the less it can move around to the rest of your environment, the better it is for your organization. And just giving you the visibility of what's even happening in the first place is critical. Now, let's step into the other piece of the puzzle. You might ask, well, does Zscaler magically tell me every vulnerability? Will this prevent every single threat in AWS? Absolutely not, right? There's a lot of attacks that have happened that an inline proxy or firewall will not see, right? And that's where sometimes we need to be able to see what's going on with our data. And that's where our DSPM solution comes in play, right? We need networking and then kind of scanning of data. Now, for anyone here, I'm not going to ask for a raise of hands, but if you're a customer of Zscaler, you may know that we've had inline web DLP for many years now. So if you scan, traffic going out, you're trying to upload social security numbers or your company's data set out to a different website, you're trying to email out to yourself, we can block that. But what if it's an S3 bucket or it's some type of file share and you're trying to share it out with someone else and that other person that's not a Zscaler customer is trying to download it, right? They're not a Zscaler customer. I'm not going to be able to see it, right? Because it's not going through our proxy. That's where this solution kind of goes hand in hand. As a customer of ours, when it comes to AWS, there's kind of 3 buckets that we put this into, right? How do we first, of course, find and discover that data and classify it? How do we look at the permissions and figure that out? And everyone knows that's kind of the tricky one, is IAM and identity is not the easiest thing in the world to do. There's a lot of solutions in the market that have been doing that for a while, right? How we find data, how do we look at identity and access? What the interesting part is, I think a lot of folks hopefully will agree with this, is that doesn't always necessarily tell you the full risk when it comes to it, because there's going to be a lot of data that you have that has excessive entitlements, but what is the lack of context that you have there? It is, you don't know what the exposure is. Now, someone with full administrative access into AWS that has access to sensitive data is bad. I think we can all agree on that. But is that necessarily the highest risk if that data is not exposed to the internet? Versus other data points that are exposed to the internet where there's like full control. Permissions, for example, right? Those are things that your teams don't have unlimited resources to look at. So that's what we're really trying to do here, is be able to give you that better context of what's the most important things to look at. So with the time left, I'm going to quickly go through just a quick journey of what that looks like just from a configuration perspective, and then hopefully just leave it for a few questions, and then I'll be over at the Zscaler booth for additional discussions if anyone's interested. So first step is, of course, when we discover the services. What are the sensitive data points? And again, if you're familiar with Zscaler, right, we have the dictionaries and engines for different things like PCI, HIPAA, social securities, credit cards, things of that nature. These are some of the data stores that we support on AWS specifically. Of course, we support other platforms as well. Once we've figured out that data, right, that's when we map and track the risks. I'm going to show the screenshot right up here, just for the sake of time. That risk is, right, putting those things together that I talked about. I'll use the laser here. In the middle right here, we have an S3 bucket, but on the left side, right, I think many of you probably have used tools with the graph interactions, is we can see what are the whats and the whos that have access to the store. That's part of the puzzle. But in this data store or object store, I have credentials, financial records, personnel records. That's bad, potentially. In this particular instance, it's exposed to the public internet. That itself is good, but this is good for when you're being more reactive, you're looking for things that you have. We can also create policies for your alerts, of course. What I'm trying to show here specifically is the most important, in my opinion, is going to be high fidelity, the predefined policies. The point being here is we're trying to make it very easy for you out of the box to be able to get the best alerts, or the most critical alerts for what's important above all of the noise. Now, no vendor's perfect on this front, I think, for any product, but telling you what's wrong with your environment is one thing, but remediating the risks is the most important part. And being able to tell you right here is the most important part, in my opinion. Kind of two parts is, okay, these are all the different high-level risks in order. What's kind of the human readable, right, where you don't have to be an expert necessarily at what the problem is. It's going to tell you, well, this bucket potentially is exposed to the internet and has full control. That's probably not a good thing, and kind of here's why. And then it'll give you an example, right? This could be a JSON response that says, hey, this is the policy that you could be using instead, right? So those are the kind of things that you can use to update your policies, whether it's your team or a different team. And there's, of course, workflow automation that we have. All of this, end of the day, even though there's inline networking, there's the out-of-band scanning, all of this all integrates into a unified platform. Again, it's really hard to do one or the other because it's very complementary. End of the day, Zscaler's mission in life is really to secure, simplify, and transform customers. And whether it's your users, your networks, your clouds, really that's our goal. And end of the day, I hope you found this at least a little bit insightful. We have 2 minutes left. If there's any questions, I'm going to say I'm on the networking team, so if there's any data protection questions, I'm not the expert on that side, but I have some of my colleagues at the Zscaler booth there. But if there's networking stuff, I'm more than happy to answer anything there. Feel free to ask. And if not, I really appreciate everyone's time.
Questions? Thank you, Zoltan.